Hello and welcome to our video tutorial. In this lesson, we're going to be looking at the applications and reasoning for Unit 3, Lesson 1, Proportional Relationships. Please remember to pause or rewind the video as needed. Let's begin. To remind yourself that a proportional relationship is one in which two ratios are essentially equal. So if you have one ratio, we'll call it A over B, equals another ratio of C over D, though let's say A over B equals C over D, that becomes a proportional relationship. And if we want to solve a proportion, we're simply going to first multiply across, and we would get A times D equals B times C. So more on the mathematics behind this a little bit later after we develop our proportion. So when we develop a proportion, and it's going to be a big part of not just algebra, but geometry as well, proportion is about looking for things that are similar, okay, and matching up things that are similar. So for instance, the unit that you have for here is going to be the same unit that you're going to see here, okay? And you're going to see that to be true for the units here and here. They're going to be similar, okay? So let's dive in and let's take a look. Read the question along with me. Again, pause or rewind as you need to. Number 1. A nutrition company is marketing a low-calorie snack brownie. A serving size of a snack is 3 brownies and has a total of 50 calories. Determine how many calories 6 brownies would have. All right, so first you have to come up with a proportion. Well, here's a ratio right there. 3 brownies has 50 calories. Or we could say that is 50 calories in 3 brownies. We could write it that way. Or we could write it as 3 brownies have 50 calories. So the way that you choose to write the ratio really doesn't matter. Just be consistent, okay? I'm going to go ahead and put calories on top. That's just going to be my choice, okay? So I'm going to go, this is my first ratio. I've got 50 calories for every 3 brownies. Okay, now I'm going to set that equal to an equivalent ratio. Now here's how it's going to be equivalent, because I'm going to put calories on the top because it's going to be similar to calories that's already on the top there, and I'm going to put brownies on the bottom. Okay, and here's what we're going to say with that. We're talking 6 brownies, so I'm going to put 6 here, and I want to know X amount of calories. So how many calories? I'm looking for X amount of calories in 6 brownies. Now, you might be able to do the math and just realize, oh, well, 6 is double 3. Well, that means the calories should be double 50, and you'd be right. The answer is 100, but let's see how we get there, okay? So mathematically, what would we do? We would first cross multiply. So 3 times X equals 50 times 6. And 3 times X would equal 300. Divide both sides by 3. And you can see X would equal 100 calories. So yes, you could kind of look at it in terms of, okay, well, 6 is double 3, so my calories must be double 50 calories. And yes, 100 is double 50 calories. So there are quite a few ways that we can work a proportional reasoning problem. Just to kind of show you, I'm going to show this to you once, just to show you that it works, but I'm going to stay consistent with the rest of how I choose to do the problem. Keep in mind, I could have chosen to work with this version of the ratio, in which case I would go 3 brownies over 50 calories. There are 3 for every 3 brownies, there are 50 calories, and that's going to be equal to X amount of calories for 6 brownies. Okay, again, cross multiply. So this would be 3 times X. 3X equals 50 times 6, which is still 300. So we get the same equation no matter which way we do it. That's why it doesn't matter how you set it up. You just have to make sure that if you put brownies on the top, it's similar over here. Brownies on the top, calories on the bottom, calories on the bottom. Okay, keep your ratios similar. Determine how many calories 21 brownies would have. Okay, so I'm going to use the same ratio. 50 calories in 3 brownies. I'm just going to use cal for calories and B for brownies equals 21 brownies and X calories. Three X equals, now we're going 50 times 21, which is about 1,050. Go ahead and divide both sides by 3. And we're talking 350 calories. Now, let's see why that answer makes sense. We originally started with 3 brownies having 50 calories. Well, 21 is 7 times more than 3. Therefore, 350 is 7 times more than 50. Okay, determine how many 14 brownies would have. Well, let's see. I'm going to go 50 calories, 3 brownies, and I'm going to set that equal to X amount of calories over 14 brownies. Now, this one's not so cut and dry because for this one, 14, I mean, that's not a multiple of 3. So it's not exactly as easy as it would be to, let's say if you were doubling the number of brownies, or in this case, 7 times the number of brownies. But we still work this. And what we're going to do is we're going to still cross multiply. Okay, 3X equals 50 times 14. So 3 times X equals 50 times 14, which is exactly 700. So that is 700. And then go ahead and divide both sides by 3. Okay, and the thing is, you're gonna get X equals 233.3. So we're just gonna round that to 233. Just rounding it down to 233 calories is like the nearest whole number. Part D. If C represents the number of calories and B represents the number of brownies, write a proportional relationship involving C and B and solve it for C. So we have 50 calories for 3 brownies. Okay, so I'm gonna use C and B for this. Equals so 50 calories, 3 brownies, and then we're talking C calories, some unknown amount of calories, and B brownies. Okay, so again, if we still cross multiply, we're looking at 3 times C equals 50 times B. So we're trying to solve it for C, so what we're going to do is we're going to divide both sides by 3. And we get C is equal to 50 over 3 times B. We will later learn a little bit further on in this unit that this part of the proportional relationship is the slope. Okay, so we'll talk more about that later in terms of how you can use that for your graphing purposes. Okay, so now it says graph the proportional relationship you found on the grid below. So, well, notice they're going by numbers of brownies, 1 brownie at a time on the bottom, and hundreds of calories for every 4 boxes going up on the y-axis over here. So I think for me, the easiest way to plot this would be, I'm going to go, 0. If I pick 0, 0, that's easy. 0 brownies, 0 calories, and that's easy. But I'm going to go over a multiple of 3. And the reason I'm going to do that is because it'll end up dividing by 3. So you'll see what I mean here. So if I have, let's say, I'm just going to make a small chart. Just to allow me to plot a few points. Okay, so this is going to be B for brownies, C for calories. So 0, that's easy. 3, okay, so if 3 brownies, if I were to put in 50 over 3 times 3, you could see it's going to cancel. I'm just going to end up with 50 calories. Okay, if I go 6, 50 over 3 times 6, that would be twice as much, or 100 calories. If I went 9, 50 over 3 times 9, that's 3 times as much. That would be 150, and so forth. Okay, plot. 3, 50, 6, 100, 9, 150. Using the graph, what is the smallest whole number of brownies a person could eat in order to consume 125 calories? All right, so here's 125 right there. Right there. We're going to go over to the graph. Okay, and you can see it intersects the graph right there. And if I go down, I'm somewhere between 7 and 8. Well, the smallest whole number would be 7. Algebraically, determine the number of brownies a person would need to eat in order to consume 300 calories. So y is equal to, or I'm going to write it this way, I'll write it C is equal to 50 thirds B, okay, which would be 300 is equal to 50 thirds B, and you're solving the equation for B. So let's go ahead and multiply both sides by 3. And we get 3 times 300, which is 900, equals 50B. And if we divide both sides by 50, we're talking 18 brownies. Okay, number 2, we have another example of proportional reasoning. It says a local animal feed company makes its feed by the ton, which is 2,000 pounds. They want to include a medication in the feed. Each cow needs 300 milligrams, that's mg, of this medication each day, and each cow consumes 15 pounds of the feed per day. If there are 1,000 milligrams in a gram, how many grams of the medication should the feed company add for each ton they produce? Well, first, a ton is 2,000 pounds. We're going to go straight to pounds. All right, and I'm going to build a ratio between first I'm going to go between milligrams and pounds. LBS, that's the abbreviation for pounds. Okay, so I'm going to go kind of in between that. Okay, and so we know that for each, let me see, there are 300 milligrams for every, so each cow needs 300 milligrams for every 15 pounds that it consumes. Okay, and there are 2,000 pounds in a ton, but how many milligrams would that be, essentially? X number of milligrams. Okay, so let's go ahead and cross multiply this. Okay, and we get 15x equals, well, 2 times 3 is 6 with 5 zeros after it. So that's 60,000. Did I miss one? I did. One extra zero, sorry. Total of 5 zeros. I only put 4 zeros. Divide by 15. And 600,000 divided by 15, we're looking at 40,000 milligrams, okay? Now, what do we know? We know that there are 1 gram in 1,000 milligrams, okay? And so we want to know X number of grams in the 40,000 milligrams we just found, right here. Like that. Okay, go ahead, cross multiply, and we get 1,000 times X equals 40,000. Dividing by 1,000. X equals 40 grams. Number 3, Quan is driving at a constant speed. Now that's kind of important because when you change your speed, then you can't really use just regular proportional reasoning. The problems become a little more complicated when you don't change your speed. Or excuse me, when you do change your speed. Okay, so he is not changing his speed. He's going at a constant speed. So after 1 hours, he has driven a total distance of 90 miles. So I'm going to kind of write that in there. So he's gone 90 miles in 1.25 hours. All I did was put that as 0.25, 1.25 hours. Okay, and so we want to know how far, X number of miles, he is going to be in 2 hours. Okay, I mean, H is the abbreviation for hours, by the way. Okay, so again, we're going to cross multiply, and we will get 1.25 times X equals 2 times 90, which is 180, divide both sides by 1.25. And we are looking at 144 miles. If D represents the distance that Quan is going and T represents the time, write an equation for D in terms of T. So we know we have 90 miles and 1.25 hours, and that equals D miles over T hours. Okay. We're going to cross multiply, then solve for D. $1.25D equals 90T. We're solving for D, so we're going to divide both sides by 1.25. And so D would be equal to 90 over 125 times T. Use your equation from part B to determine how Quan drives in 15 minutes. Okay, well, 15 minutes is 1/4 of an hour, or 0.25 hours. So the distance would be 90 over 1.25 times 0.25 hours. So 90 times 0.25 divided by 1.25 means he will have driven a total of 18 miles. Quan is driving a total of 234 miles. How long will it take him to make his trip to the nearest 1/10 of an hour? So we're going to round it to the nearest 0.1 hours, okay? So again, we're going 90 miles over 1.25 hours. And that's going to be equal to 234 miles in X number of hours. Kind of what we're looking for in this one. So 90X equals 1.25 times 234, which is 292.5. Go ahead and divide by 90 both sides to get X by itself. Right, and it's 3.25 hours, but if I round it to the nearest 1/10, let's see, to the nearest 10th right here would be, what, 3.3 hours? Now, in our reasoning section, talks about unit rates. So unit rates are proportions where we compare the change in one variable to a change of 1 unit in the other variable. We typically report speeds in miles per hour. That is a unit rate. A speed of 60 miles per hour should be interpreted as 60 miles traveled per 1 hour of time. When we say that fat has 9 calories per gram, that is a unit rate because we are comparing 9 calories to 1 gram. So convert each into unit rates. Some will be decimal unit rates. So this one would be 24 feet in 3 seconds, we'll just divide the two and we would get 8 feet per second. 30 pounds per 8 boxes would be about 3.75 pounds per box. And 50 calories in 20 chips is 2.5 calories let's write it down here. 2.5 calories per chip. I hope you found this lesson tutorial to be helpful. Again, pause and rewind as you need to. Thank you and see you next time.